Hi, Calculus 1 students. We're in the section of derivatives, and this was a problem asked in the fall 2014 final exam. It's to find the derivative of this function using the definition. Okay, we'll see easy techniques soon how to differentiate this in pretty much just one step. But for this problem, we are asked to use the definition. And then we want to use the derivative to find the equation of the tangent line to f at x equals 1. Okay? Now, be careful because of the word equation over here. Normally, we know that the derivative gives us the slope of the tangent line at x equals 1. It doesn't merely give, it doesn't give the entire equation. So after that, we have to figure out the entire equation using pretty much high school techniques. So finding the derivative will be step number 1. Okay? And find the equation will be step number 2. Okay, so this will be step number 2. All right, so let's begin with the derivative. So remember f prime of x. Now remember that we have two definitions. One that is kind of simple to write but involves two variables, x and t, and one that involves x and delta x. Let's choose the delta x definition. So we have that the derivative will be the limit as delta x is approaching 0 of f of x plus delta x minus f of x over delta x. Okay, now we have to replace everything right. Let's put it this way. F of x is easy, okay? It's just this. So after the negative sign, we have 4 minus 3x. And delta x, there's nothing to replace. It's just going to be like delta x like this. Now, hopefully, the next term won't take too much space. Otherwise, I'm stuck erasing that. But here's what it is. Look, 2 over the square root. 4 minus 3. And the idea is, every time you have x, okay, so here you have an x, you replace that x by x plus delta x, okay? So in other words, this x over here will become in this term x plus delta x. Okay, not bad, just a little bit crowded. I'm going to do slight adjustments and we're going to be good. Okay. So I'm just extended that square root and that fraction, and I rewrite the other term. And I should be good from there. Okay, so this is it correctly written. And believe me, this is the most part of the problem, writing this correctly. This is pretty much what's the hardest, okay? Though, I should say that the limit is, to say the least, tedious. I wouldn't say it's hard. It's tedious. It uses more than one limit technique. So if you want, you could directly substitute, but by the nature of that definition, that direct substitution will always give 0 over 0. So you can already proceed doing some algebra. The first thing that I would do is, since we have a complex fraction, I would put everything under common denominator. So how will that happen? Or actually, remember that you can also multiply both terms by the least common denominator. So yeah, let's just write this over here. Multiply both fractions at numerator by their LCD. Okay, so what's gonna happen is that this least common denominator will move out to the denominator multiplying delta x. So that will be delta x times the first denominator, 4 minus, and at this point we can expand it, okay? Minus 3x minus 3 delta x. And then we have here the other denominator, which is 4 minus 3x. Okay, the numerator is slightly tricky. So here, by multiplying this term by these two things, what we will get is twice this one, because after multiplying by this, it will cancel with the denominator that's already there. So we will have here twice that's it, square root of 4 minus 3x, minus twice the other denominator, so square root of 4 minus 3x minus 3 delta x. Okay, so first off, before doing anything else, remember that your goal is to cancel a redundant zero, okay? And at the denominator, you already have it. You're looking forward to having it at the numerator. So for that reason, we're leaving the denominator as it is, and we're gonna rationalize, okay? And actually, I'm gonna write the result over there. I'm just gonna mention that this is the result of rationalizing. Rationalize the numerator. Okay, so what's gonna happen is that the numerator is gonna be simply the difference of their squares. So it's gonna be still the limit as delta x is approaching 0. That doesn't change, you need to put it down. But it's gonna be, yeah, I'm gonna, do I square it? Yeah, I'm gonna square them immediately. So it's gonna be 4 times 4 minus 3x minus 4 times all of the inside of the root, right? 4 minus 3x minus 3 delta x. Now the bottom is going to get gigantic, okay? Bear with me. So it's what we have over here. So delta x, square root of 4 minus 3x minus 3 delta x, times this square root right here, 4 minus 3x, times the conjugate, okay? So I will write it in here. It's basically this, but with a plus sign in between. That's it, okay? So here we go. Okay, there we go. Close the bracket. I told you it was gigantic. There you go. I need to extend the line over here. All right. Now I'm going to erase everything that's on top, and we're going to simplify a little bit that beast. Actually, we're not going to do much with its denominator. What we're going to simplify the most is the numerator. Because remember, we already have the 0 at the denominator, so we don't touch the denominator at all, okay? We just want to get a 0 at the numerator. So I'm erasing everything except that last line. So you might want to either take this down or just rewind the video when you feel it's necessary. Okay. So then what we do is we simplify everything that's here. So unfortunately, I'm stuck copying the denominator as is. Okay, so we have delta x, square root of 4 minus 3x minus 3 delta x, square root of 4 minus 3x, multiplied by the conjugate, and I will drop the color code now. One thing that you can actually do here, and I will do it immediately, I think it will be helpful, is to factor out that 2. Okay, so that 2 over here, it's a common factor. Let's actually take it out. So it's going to be like a 2 that's going to be hanging like this, or even better, let's put it at the front. Okay, times the conjugate that is just written without the 2's. Okay. All right, lastly, we expand all this mess in hope to get something that will give us 0. So what do we get? Actually, there's something interesting here. Yeah, look at this. Here, I'm just gonna take that part over here, and I'm gonna show you how the simplification operates. This can actually help your algebra a lot if you know this kind of technique. So this I'm not gonna change. I'm not even gonna expand. Look at this. Okay, I'm gonna expand it, but this way. Okay, so minus 4 minus 3x, and then plus 12 times delta x. Okay, so actually what I did is I considered this bracket and this term. So I expanded over these 2 terms instead of these 3 terms. And notice how these 2 cancel. So, which means that at the top, what I'm left with is just 12 delta x. All right, and we are almost done. Okay, I'm gonna do 2 steps at one because I don't want to rewrite that beast. So first, notice that the problem is pretty finished, almost, right? Because we have that redundant 0 that we are canceling, and then we are directly substituting. So what will happen if we are directly substituting? So 12 over 2, that's gonna give us 6 over, okay? Then directly substituting here will give us 0. So this and this will actually pair up. It will actually, oh wait, I won't do the pairing yet. Okay, so this turns into 4 minus 3x. This stays, the square root of 4 minus 3x. And now have a look at this, okay? So what I have here is square root of 4 minus 3x plus, and this turns into another one. So because this is approaching 0, right? Okay, so what do we have? These two are multiplying with each other. So yeah, I think, or actually, yeah, I think it's fair. What we have here is, so these two multiply with each other. So that's going to give us just 4 minus 3x. And these one are going to add up. So we're going to get another 2 square root of 4 minus 3x. Okay, I'm going to erase that last line. And I need to change my blue at the same time, I believe. Yeah. And then at this point, you could just simplify this, the 6 over 2. That's going to give us 3. I will do something a little bit slightly more instructive. So 6 over 2 is 3. That's correct. But pairing these two things will actually give us, by the rules of exponents, 4 minus 3x to the power of 3 over 2. So this is the derivative. Okay, so that's the result, by the way. F prime of x is equal to 3 over 4 minus 3x to the power of 3 over 2. But remember, this is just step number 1. So what I'm going to do is actually, I will copy this derivative down here, and I'm going to erase everything in order to do step number 2. All right, so I erase everything here. Now, remember that the slope of the tangent line at x equals 1 is given by f prime of 1. Okay, so let's actually just state that first. The slope of the tangent to f at x equals 1 is f prime of 1. Okay? That we know already. And we know that the best way to have this is to get the entire derivative and just replace 1 in it. So f prime of 1 is equal to 3 over 4 minus 3 times 1 to the power of 3 halves. So you just replace 1 in your formula, and what do you get? 4 minus 3 is 1. There you go. So 3. That's the slope. So is the slope. Remember now that we are not merely looking for the slope. We're actually looking at the entire equation. Okay? So the equation of the line is y equals 3x plus b. Okay, the 3 we got it from the slope, by the way. So here this 3 is actually the slope. And remember that this b right here is the intercept, the y-intercept. Now, how do we find b? You should remember that the only thing we really need to do is to replace a point which we know is on the line. And that point is 1 f of 1. So knowing that 1 f of 1 is on the tangent line, we can replace it in y equals 3x plus b to find b. That's what we are looking for, right? Okay, so now I'm erasing this. Now, f of 1 is easy to find. What we do is we take this function and we replace 1 in it. Okay, so as a result, this will simply give us 2. And then what we do is we have f of 1 is equal to 3 times 1 plus b, which means that 2 is equal to 3 plus b. So you simply solve that equation for b, and you get that b is equal to negative 1. So as a result, the equation of the tangent line to f at x equals 1 is y equals 3x minus 1. This is it. Okay, sorry for the video. It was a little bit long. The derivative was just taking a little bit more time than expected. But there you go. This is it. Hopefully this was helpful. And see you in the next video.